Ba-da-ba-bum. Whatever. Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Dan Maloney.
This is episode 264, Cheap Minimills, 65-in-1 Electronics, and Time on the Moon. This week in the news, I thought it was interesting that Flipper, that is the little orange hardware, mostly wireless hardware hacking tool, responded to the Canadian government's allegation that it was being used to steal cars and thus should be outlawed in the country of maple syrup. We actually covered this when it first came out. Maya Posh wrote up a piece called Why Stealing a Car with a Flipper Zero is a Silly Idea. And again, the reason is basically because all car keys use rolling codes for the last 20 years. And so you can't just do a simple replay attack like you could ages ago, I guess. We also published a video by an automotive locksmith saying exactly the same thing. And then this week, Flipper themselves finally came out and said, hey, this is not very likely to be the way these cars are being stolen. Go pick on someone else, and started up a petition that you can go and sign, especially if you're Canadian and or if you think that Flipper is getting scapegoated here.
I mean, it's kind of a rough position for Flipper to be in because they have to basically admit, well, no, our device isn't that good. You know, it can't steal a current car. Sure, I can steal an old car, but yeah, it's a little bit of a weird position to be in. The people have kind of exaggerated what the dongle is capable of. I guess what they really don't like, probably, if they found out about it anyways, is, the fact you can snoop in on things like grid-connected smart power meters and things like that. So that's probably where they'd start really losing it if they realized that you had a tool that could do that kind of stuff. But cars are bad enough.
What I find really weird about this, though, is that there are, of course, CAN bus hacking devices that give out the unlock the car, start the motor things for certain models of cars. And you could buy these on eBay. So there are actually legitimate, this is a device to help you steal a car devices out there. And those are being sold, whereas the Flipper got picked on, I guess, just simply because it's so popular.
Publicity. Yeah, it's the one that's drawing all the fire right now.
But it's the wrong device. It's the,
exactly
the innocent popular guy who was walking down the street when the shady crooks were actually stealing the car.
Exactly.
Bah. It's our job as the smart people and the educated people in the room to let the politicians know. So if you feel motivated to do so, head on over and sign up that petition. And then all that leaves is, what's that sound?
Alrighty.
This is a journey into sound.
What's that sound?
What's that sound?
Oh, I'm listening to a FLAC, not a wave. Okay.
Perhaps. I probably change the format every week.
Oh, man. I got that one.
Do you? So did Al.
Sure.
What you got?
Yeah, that's a spinning reel.
Yeah, totally.
That's the drag on the spinning wheel. A fish going out with your line set. Yeah, that brings back some memories.
Very good. Yeah, this was I'm not a fishing reel connoisseur, but apparently there are such people. And
sure.
The super astute among you would note that this is a Hardy marquee reel. The brand of the reel in question. Love this comment from David M.H. The reel from a fishing rod, I'm sure someone else will have been able to pinpoint the specific fish being caught. I love that. It's that sounds like it's about a 7-pound trout.
Oh, someone has probably taken it apart for the background sound there, the birds. That'll give you a location of where those birds are, native. And maybe from the sound of the brook, you could tell if it's in the rapids or in the stills. Don't encourage them. Don't encourage them.
There is a little bit of a river background noise, and I think that tipped a lot of people off. Oh my God, Chaz Naster, the drag on a closed-faced fishing reel with a 3-ounce sunfish on the line. See? I knew somebody would say this. I knew it. Hackaday does not disappoint. There were a ton of answers here. So many that, in fact, I'm still counting up how many are correct. Give me a sec. My God. Some of the best wrong answers include someone swinging a ratchet socket wrench around by the socket end. Admit it, you've done that.
Sure.
Some winding and unwinding of cameras, various crank type noise makers. So I finally tallied these up. We had 94 responses. Of them, 80 were correct. So congratulations, all you fishing reel people. Some of you were way too specific. You got the brand of fishing reel wrong, but I'm not going to penalize you for that one. It was actually from a YouTube video where they were just demoing the sound of this particular reel because it was particularly nostalgic for apparently a whole bunch of people, because the Hardy marquee is on a million videos where people just record the sound of it, which is pretty funny. All right, this is such a big number. I'm heading off to the internet to find myself a random number generator. See if we can find a good one this week. One that I haven't used? randomnumbergenerator.org. It says it's cryptographically strong. It's random enough for me. We got numbers from 1 to 80. And my random number is... What the heck is it doing? It's just showing me a whole bunch of numbers. Oh, and I'm supposed to click stop. Okay, here we go. I'm closing my eyes and clicking stop. I got number 7. Congratulations, number 7. Who is? Fishing Reel, Spike Snell. Congratulations. I'll be shooting you an email. Get your shirt size and your address. Send you out a Hackaday podcast t-shirt. And everybody else, thanks for playing along. That was a tremendous number of correct answers. You're all winners in my book, but we don't have 80 t-shirts. So tune in next week.
But that's not legally binding.
So tune in next week for another sound and your chance to win a Hackaday podcast t-shirt. All right. Well, my first hack this week is clever Eink driver does 32 levels of gray, avoids update flicker, and more. And this is a superb hack by Anti-Res working on a regular black and white e-ink display. This one seems to be targeted at a couple specific displays, and that's because they use a common driver, but that makes you think that it'll work with most displays that use this particular driver. That is the UC8151/IL0373, if that means anything to you. This is a MicroPython-based driver for this thing. He manages to take a black and white display, just like black and white, and do 32 levels of gray. And this isn't the first time we've seen this trick before, but it is one of the most refined and most accessible implementations of it. And if you head on over to his GitHub page, the README there is basically a treatise about e-ink displays, how to drive them at all, and how to get different gray levels on them. And that alone is worth your visit. E-ink displays have a charged side and an uncharged side, and they put either a positive or negative voltage on the chargeable side, that is called the pixel voltage. And then this pushes negatively or positively charged microcapsules closer or further away from it. And with the black and white one, of course, you've got black microcapsules and white microcapsules. I guess you attract the white ones to the back and the black push the black ones off to the front, and then you see black, or vice versa. The trick to getting grayscale then is you woodgie them around so that, some of the black ones are toward the front, but not all of them, or they're kind of halfway to the front. And there's kind of, because of the way these things work, there's always going to be kind of a gradient of them spread out through the kind of vertical dimension between the pixel voltage layer and the transparent layer. All of these displays have inside them kind of secret lookup tables which run these patterns of putting positive, negative charge on the pixel elements in order to manipulate these little charged black and white microspheres around. And the trick here is figuring out a good set of patterns to put them in a known state and then move them around into the target color you want. And that's like, for instance, why you see a lot of displays flash black and white on refresh, because what they're doing there is they're kind of pushing all the little microballs into a known place so that then when they come back up, they can ensure that only the cells that wanted to be black are black still. Doing it with gray is, of course, a little bit trickier, but that's what the software does for you.
I would love to see one of those frame an hour movies on a display like this. I think it would look fantastic, especially an old, a black and white movie that was, from the era when the cinematographers knew how to light for black and white, and, the look was just right for the medium. Something like Psycho. I think I remember seeing a project that we covered, and someone had a frame every hour or something like that from Psycho. The shower scene would be would be awful to drag it out like that, but I guess you win some, you lose some. But yeah, the quality of just this little tiny display, which looks like, basically just looks like a badge, credit card size, is just fantastic. I've always loved the look of Eink and was absolutely fascinated by it the first time I saw one on was either a Nook or a Kindle. One of my kids had, turned the power off and there was still a display. How does that work? And look at the level of detail that's in there, the sharpness and the contrast between the white areas, which weren't really white. It was kind of more of like an ivory sort of thing, but the blacks were, nice and saturated, just gorgeous. Seeing the improvements that were accomplished here is,
There's also all sorts of things you can do. You mentioned the slow movie displays, but I think this one also lets you update by storing the current gray level value of all the pixels in kind of a frame buffer. You can actually send it the patterns that are just right to bump it up or down a level in gray as well. So you actually don't have to do full refreshes all the time. And this is doing tricks like that. And I think it gets, I'm scared to even say it. It sounds totally impossible that you could get like 50 hertz refreshes out of this. But I think he may be claiming to do that. It definitely makes you want to get one of these displays and see if you can play around with it. And play around with it you can, because this is actually a MicroPython library. So it's going to be super easy to implement your own code here. And it really looks like you kind of allocate a frame buffer and then say eink.update and it goes. So in traditional Python/MicroPython way, everything's all wrapped up in a library for you. So it should be very easy to play around with.
Okay, first up for me, are Minimills worth it? I hate to bring Betteridge's law of headline writing into things again, but I think this is one of the cases where the answer isn't necessarily no automatically. This one comes to us from Someone Should Make That, which I just love that name, very optimistic. And he takes a close look at the current generation of Minimill clones that are out there. And basically these are desktop versions of a Bridgeport sort of knee mill, that sort of layout anyways, but in a much smaller, much less powerful form. Spindles are powered by a little, either a brushless motor or simple DC motor, very, very low power. They're more of a hands-on tool than a CNC router, but kind of in that same cutting category. People generally seem to think that they're only good for plastic and aluminum. You can't cut steel on them. You can't cut very fast. You can't put big tools on it. There's no rigidity because there's no mass. The gears are sloppy. The lead screws are terrible. The this, the that, and the other thing. Everybody dogs on these poor little devices, and there's some validity to that. But, like I said, I think last time I was on, when I talked about this with mini lathes, any lathe is better than no lathe, and any mill is better than no mill. I think that's the take-home message here, and it's very similar to what I said about the lathes. You can go out and find somebody's old mill, somebody's old lathe, take it on as a project, take it home, a nice South Bend or a nice Bridgeport mill, but you don't know what you're getting into. You don't know if it's just something that someone decided, I don't need anymore, and it's perfectly fine except for maybe some, dirt and debris and maybe needs a little adjustment here and there. Or is it something that's so clapped out that you're not going to be able to do precision work at all? At least with a mini lathe or a mini mill in this case, they're a known quantity. You know where they suck. So you can go in and fix the things that you know are wrong with that. And he addresses some of these things in the video. The chief one that I saw that kind of couldn't believe at first that's the way that they chose to make this. The fact that the whole column can be angled something other than 90 degrees relative to the table. So you can loosen a single bolt on the back of the column that holds the column to the bed and swivel that 45 degrees this way, 45 degrees that way. If that's not tight, then you've got a problem. and you're relying on a screw thread to stay put through vibrations and use, and that maybe isn't the greatest. But he easily fixed that. He found that was a problem. He found it was hard to trim the mill in, so adjusting that was relatively trivial, and making sure it was tight and stayed tight is just something you would probably have to check on a daily or weekly basis, depending, every time you're going to use the mill, make sure that bolt is tight. And there are certainly other modifications you could make. You could put a pin in it. You could, there's a whole bunch of things that you could do to make that more mechanically less compliant. How about that? Less mechanically compliant. And there were some other points here and there, but none of it was really a deal killer. I'm sure there's bad ones mixed in with the decent ones. You might get a lemon, but that's true of pretty much anything. So the takeaway is, are Minimills worth it? And I think yes, especially if you don't have a mill. And I think I would probably, I'm getting to the point where I'm just like, plenty of stuff I can do with a mini lathe and a mini mill sitting together on a bench someplace. Make it a nice, sturdy, heavy bench to kind of absorb some of the vibration, invest some money in tooling. Get to learn how to do this stuff. All I know how to do on a mill is what I've seen, Quinn Dunkey do, or this old Tony, watching machining videos. That's not the substitute for the muscle memory and learning how to do things and, actually getting in there and saying, oh, okay, if I, feed too fast, I'm going to send the end mill across the room. That stuff comes with experience. You don't get any experience if you don't have a mill. So the answer, I think, is yes.
There's so many people who have gone through these mills and, tried to fix them up and make them work, that there's, a million proven ways to make them better. And one of the things I think that's neat about kind of machine tools is that they're actually machine tools. They're for making more machines with. And you can take a tool like this and, make the parts you need to improve the very machine on the machine. And, that's kind of a fun project too, if you want to start taking those steps. The other thing that's cool about this one, I think, is that it's a fully manual mill. That means you kind of get to learn hands-on how things go. Whether that's a good thing or a bad thing in the days of CNC everything, I don't know for sure. I mean, it's kind of fun to play with manual mills because you get kind of an intuitive feel for what the right feeds and speeds are just by running the thing. On the other hand, when you later step up to bigger CNC things, you're just going to end up looking these up in a table anyway and just plugging in the right number to begin with. And the whole trial and error experimenting thing ends up being not so useful in the end. I guess it still gives you a feel for, when you're cutting too deep and when you're really stressing the machine and stuff like that. So you can learn some stuff from it.
There was another guy, Artisan Makes, that's the name of the YouTube channel, and he's got one of these and did some ridiculous tricking out, including, I think it was a 3 horsepower motor, which, dwarfs the rest of the machine. And he's done all kinds of mods on his lathes, on his mills, and then just ended up, outgrowing them and getting something bigger. Okay, good. That's kind of the way it should be. You should start where you can start and go from there. And don't let no mill be an excuse for not taking on a project when you can just go pick up one of these things for a couple $100.
My next hack comes from Alex Lau 5112, Weird Things to Do with FPGAs. And when I read this title, I thought it was going to be, FPGAs and applications that are wrong for them. But no, this is yet weirder still. He is looking at kind of all of the gray zones that when you take an engineering course about how to use FPGAs, you're told never to do. And he's instead pushing into all of these kind of weird, undefined behavior type areas and seeing what they do. And it's a great catalog of those. He starts off the article with, my favorite phenomenon in digital circuitry is when digital threatens to become analog again. And that is the spirit here. If you look close enough at any digital circuit, it's actually analog under the hood, right? Like you think it's making a voltage transition from 0 volts to 3 volts instantly, but it's not. There's a slew rate there. And when things get fast enough, of course, you have to worry about them. And this is one of those things that they actually teach you in kind of straight up engineering FPGA courses, that you need to allow a little bit of propagation time and settling time for these things to get up to their end levels. And so, if you're taking in unknown inputs, you end up buffering it and stuff like this. Alex is poking at all of these areas to see if he can get random and odd behavior out of it. And basically that boils down to figuring out how the propagation delays here increase or decrease depending on how the chip was made physically, so its process, the temperature it's at, or the voltage. And also, in probably my favorite, he also looks at strain on the chip. And in order to turn an FPGA into a strain sensor, for instance, you make a ring oscillator. So you take a bunch of NOT gates and you put them in a circle. So this one, turns on when its input is off, and then the next one in the circle turns off when its input is on, and you just loop them around, odd number of them, loop them around, they make a chain. And the speed at which the changes propagate around this circuit depends on all of these kind of real physical quantities, among them strain on the FPGA. So you can actually use the slight frequency variations there as a pressure sensor, but also a temperature sensor. You can use it to read the voltage. His main tricks to look at it include making ring oscillators and counting how many times they go around. He also does one with a tap delay line, which is really neat. So you just take a value in here, you pass it to the next one, you pass it to the next one, you pass it to the next one, and you read it off along the way. You can use that to figure out in kind of single units of whatever your fabric's propagation delay is, how long a pulse is or how long it's been since the pulse has hit. And that's really neat. So he uses those to poke at kind of these analog-y gray zones inside the FPGA. Last up, he also looks at physically unclonable functions, which are things like when you just power the chip up. If you have a bunch of memory, are they ones? Are they zeros? This turns out to be a kind of a process thing and different often from chip to chip. You can find zones where there's kind of consistent behavior for a given chip, but then different behavior across chips, and that's really fun too. This is like a deep look at the kind of non-logic parts of FPGAs, the metastability, the parts where everything falls down, breaks, and goes wrong. And he's kind of doing a literature review here of all of these weird gray zones. So if you're at all interested in that, very hacky, very FPGA, give it a look.
As you're going through that, I'm thinking, yeah, it's very true that digital's just analog with the layer of abstraction on top of it. And I've known that for a long time. Yeah, any idiot can count to one, right?
If you squint hard enough, everything becomes digital too, right? Like if you can only see two colors, everything's black and white. So
true.
That also works. Like I said, these are all the things you're taught to avoid studiously if you are doing FPGAs, quote, right. I just love the catalog of a million ways to do it wrong.
Okay, next up for me, a 65-in-1, the 2024 way. This one was a serious nostalgia bomb for me. When I first spotted this in Hackaday I/O, the first picture, the banner image was like a flash of memory. I finally remembered what this thing looked like. I had this very same 65-in-1 electronic project kit from Radio Shack. Back in 1970, I'm going to say 6, maybe 75, 76, somewhere around there. So I was probably, only 11 or 12 years old. And this was the hands down best Christmas present I ever got. Everything else pales in comparison. This started everything for me. The only reason I'm here right now talking about this kind of stuff is because of the 65-in-1 electronic project kit that my parents got me for that Christmas. So seeing this, just like, and the thing was, I couldn't remember what it looked like really. I kind of had a vague sort of memory of, the cardboard with the spring terminals and the components that were on it. But the layout of it, the colors and all that stuff, I had no distinct memory until I saw this picture. And I was like, oh, yes, that's it. That is the exact thing that I had and spent hours upon hours upon hours with. Well, Tom Thowen was lucky enough to score one off of eBay or something like that. As original as possible. It came with all of the parts, I think, except for maybe the little Morse key that they gave you and things like that. There it was, all together in one place, just like I remembered it, just like he remembered it too. And he started thinking, what would it take to make a modern version of this? The answer is a gorgeous project. Each individual panel and for those of you who aren't familiar with the 65-in-1, just go check the article out. And as soon as you see it, you'll see what we're talking about. It had a collection of parts, a bunch of resistors, a bunch of capacitors, a couple of different transistors, transformer, solar panel, blah, 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 a whole bunch of different stuff. What Tom did is take each one of those blocks of components and render it basically in a printed circuit board. Yeah, the part gets mounted. There's a little silk screen to indicate what the part is, the schematic symbol plus the value. And rather than springs like we used in the cardboard ones, which really were kind of crappy, put in some DuPont connectors. I've seen an update to this project just this morning, I think. He's found that his jumpers are breaking off inside of the female connectors just because he's getting over exuberant and pulling them out just like we did when we were 10 or 12 years old. So he's breaking off pins. So he's gonna strip all this out, all the female headers, and put in male headers, and then connect everything with female jumpers, which I think is a really good idea. Anyways, he's got a panel for resistors, a panel for capacitors, a bigger selection of transistors and diodes, and he doesn't really recreate the whole little diamond section that had the SCR and the different diodes, but that's fine. Some concessions to modernity are perfectly fine. The other concession he made is he didn't put on any of the stuff for making radios. So there's no ferrite antenna like the original had. There's no variable capacitor. At least currently, the modularity of this would certainly lend itself to putting other components on. The whole thing just is a real trip back. And even though it's rendered in quote unquote modern electronics, because it's all through hole components, he didn't go surface mount, which I don't think there's any surface mount there. No, there's no surface mount. The fact that everything is out there laid out in front of you, just like it was back in the 65-in-1 days. Plus it's on a wooden board, a laser engraved plywood board. Really harkens back to the wooden box that this thing came in, with a little tray on the side for organizing your jumpers and all your extra parts and stuff. Super nice job. Still working on it, and people seem to really have latched onto it in the comment section on Hackaday.io. Plus in the comment section to the article. I love it. Hats off. Good job.
That's an absolutely super idea and a really clean implementation. I have to say, I really like the feel of those little machine pin headers. You could substitute those instead of using, the normal square pin headers, the ones that are round and have the little, equally round sockets. I just like plugging those in, like in a tactile way. I know this is dumb, but beats the heck out of those crazy springs. But yeah, what a cool project. What a great idea. And, again, a really simple project. It's like a breakout board for a capacitor, and a breakout board for a bunch of resistors, and, a breakout board for some pots and stuff like that. But boy, if you want to do this kind of hands-on learning that you could do about easy electronics circuits, this is a great way to go. And the only thing that's missing then, of course, is whatever that book was that must have come with it that has
book.
These
right.
65 projects, because this is a whole bunch of parts. Now you got to do something clever with them all. And I think half of the game, at least, is thinking up the right set of kind of minimal projects that teach you the maximum things about, how to bias transistors, or what does a transformer do, or any of that kind of hands-on electronics. So that's the part that's missing, but also it's kind of an invitation to creativity for modern people who already know what they're doing. It might be neat to see a kind of modern, updated take on what the right little 65 projects are to do with this thing.
Yeah, and part of the charm of it that made it accessible to me at that age was the fact that the lab manual, which was basically the entire size of the box. I remember it was, the manual went in the box, and then the cover went on, and it just was like one solid unit. You just can put it away. The manual had these little cartoons. They had the schematics, they had the wiring diagrams and descriptions and all that stuff. A picture of what, this thing is supposed to look like at the end with all the wires going here and there. But then they also had these little cartoons like, I'm the 2SC transistor, I amplify the blah, 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 or I'm the diode, I do this. And it was childish probably for a 12-year-old, but it still managed to get the message across of what all the components did, how they work together. Like I said, set me up for a lifetime of doing this stuff. The first thing I did when I saw this project, kind of did some mental math, family math. And I go, okay, which Christmas was that? Okay, that must have been 1976, blah, 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 And then I went to the Radio Shack catalog archive because, yes, there's a Radio Shack catalog archive, and looked up the 1976 catalog, found the page that it was on. And this thing cost $21.95 in 1976. And I was like, first of all, I was like, oh, well, it's not cheaper than I thought. Wait a second. Adjusted for inflation, that was a $121 Christmas present from my parents, which must have been absolutely crippling to them at the time. And I thanks, Mom. Thanks, Dad. Your money was well spent. I've made that back and more off of electronics. So thanks a lot. Yeah, thanks to Tom for kicking the nostalgia bucket and having it spill out and having this come out. It's a great project. Kicking the nostalgia bucket?
I don't know what that means.
I don't know what that means.
But now you have me looking through that old Radio Shack catalog.
Oh God, I know. It's a deep, deep dive.
That's funny. Well, flash forward about 10 years from the mid-70s into the mid-80s. This is a really cool cataloging project by Dandu of the real hidden messages in music. And this is really fun because it is not about secret messages, but about computer programs stored in vinyl and CDs and cassette tapes that go along with music. And at first, this seems kind of weird, especially from a modern perspective, to be like selling you a cassette tape of your band's music and then put a Sinclair ZX81 software on the thing. But if you hearken back to the old days, people actually were storing data, of course, on cassette tapes, and every once in a while you'd even get a vinyl record with data on it in a computer magazine. And so there was already this kind of weird mixing of code and music in the world. And so, of course, the next logical step is for bands to put out what essentially amount to music videos to be run on your home computer in a parallel track to the audio that they're playing. And so this is a collection of kind of this time, but then a lot of these are also modern. So some of these are from late 80s, early 90s. A lot of them run on these kind of old computers. There's a lot of Sinclair, there's a lot of Apple II, few Commodore 64, but then some of them are also in the modern era, and so people are still playing this same old game even in, the last 15 or 20 years. So it's really fun. Anyway, a lot of these have videos, and that's kind of the big work that Dandu's doing here, is chasing these down, running the programs, and trying to sync them up with the music they go with. It's absolutely fun to watch, and some of them are like kind of proto demo scene things, and some of them are just like random graphics of the kind you could make back then with like a limited color palette and ASCII blobs on the screen like you could back with like the ZX Spectrum or something like that. Really interesting. Some are much more ambitious and are actually synced to the track they play along with. Funny enough, I was listening to a, kind of weird Texas chippy band called Tree Wave back in the early 2000s. And this is all on CD, right? And at the very end, there's like, screw, screw. And I'm like, oh my God, I wonder what that is. And so I go looking around, and finally it's a Commodore 64 program. And I in the mid 2000s, managed to pull up a Commodore 64 emulator and finally played that on there. And it does turn out to be, it's a little sound synthesizer program for the C64 that they wrote and apparently used in performing some of the album and then tagged on the end as just, kind of a gag, right? That's listed here on this list. So if what I thought was the most possible obscure program was actually that got smuggled into an otherwise normal album is actually represented here. So check out Cabana EP by Treewave. Go figure. So this looks like a really pretty good list. Have fun. I mean, there's music programs, there's some of it's modern and ironic, there's work by Aphex Twin here. The ability to do this is owed to all of the modern emulators. I know he doesn't have a room full of all of these computers somewhere that he can play these out on. And it's really just a question of finding a Dragon 32 emulator or an Apple II emulator. But also some of these projects ended up being intricate enough or complicated enough that they have their own page on how he managed to pull it off. And so the documentation here is really cool too.
Okay, my last pick is Magnetic Power Cable Makes Mobility Scooter Much Better. This is a great hack, and it's not a difficult hack. It's nothing complicated. Nicholas Frost basically made a DIY version of a MagSafe connector for his father's mobility scooter. And that's great, and we'll talk about that. But the thing that I think is really great about this is the lesson it teaches about when you know you're solving the right problem. The mobility scooter, the hack itself, is simple, like I said. The problem was that people with mobility issues, gross motor mobility issues, like walking around, often at the same time will have fine motor skill issues. And the charge port on this particular mobility scooter is basically just an XLR connector. And it might not seem like it needs a lot of, manual dexterity to operate an XLR, but think about it next time you're actually manipulating one, if that's something you have in your life, or any small connector. There's a lot of fine motor skill that goes in with even plugging a USB cable in. You don't know it until you've lost it, temporarily or permanently, or you're in the process of losing it. And I think that seems to be what's going on here. Nicholas wanted to come up with a way to make it easier for his father to plug this mobility scooter in so he could charge it. He did it with, surprise, surprise, 3D printing, because that's perfect for this application, parts that don't exist anywhere else. And basically came up with sort of a mega-sized version of the XLR connector, whose contacts are commercially available magnetic connectors. They pass 10 amps and they lock together with magnets. I had no idea these things existed, that you could buy them off of AliExpress, but you can, and they're cheap and they're perfect for the job. So the 3D printed part make it easy to plug in. It's big and chunky, easy to hold. As a bonus, it doesn't get rid of the original XLR charging. That's still there. So this is basically just an adapter that goes between the stock charging cable or in the mobility scooter. So this is a quick and simple project, right? Well, no. Actually, it ended up being about a year because Nicholas started going down the wrong road with this. He was thinking that it could be a platform or something that you could drive the mobility scooter onto and a robotic arm would come out and make the XLR connection. And he tinkered around with that, he says, for about a year before he finally realized, wait a second, the problem here is getting the scooter to charge with someone who's got limited but non-zero hand dexterity. So he just needs something bigger, to actually grab onto and plug in. And within a day, his dad is charging the scooter because of 3D printing and those magnetic contacts. Instead of solving the wrong problem, he finally figured out what the problem was and fixed it the correct way. Maybe the non-sexy way. I mean, everybody wants to, build, the cool thing, the gee whiz, but sometimes it's not the thing that actually solves the problem. And I think that's what he learned here.
Yeah, I do think that's the big lesson here. I mean, those magnetic connectors are undoubtedly very cool. But the real lesson here, as you said, is that, you don't need to build a robot that can plug in XLR connectors. What you need to do is swap those damn fidgety connectors out for something, bigger and the right scale for the person who has to use them. And that, of course, is the whole lesson here. It's actually a really sweet design, though, a plug that would kind of self-seat. And the way he does it here is actually really clever. It's got a kind of a wedge, and the plug part has a triangle in it that fits in this wedge. And so you just kind of put it against the face and slide it down until it kind of self-centers and self-seats in exactly the right place. And then the magnets take over. And that's actually a really great locating feature, on both the socket and the receptacle or whatever they are here. Designing with that kind of thought in mind, like how to make the target as big as possible that the person has to hit, is totally useful for people who have, wiggly arms or whatever due to disability. But it's also got to be easier to use and more satisfying to use for someone who's able as well. And, like you said, I plugged in 1 million XLR cables in my life, and you're in a loud venue and you're trying to plug these in with no lights behind the stage. It's not easy, yo. If they just had bigger connectors, I'd be doing it better. So I do think it's really cool, and I do think there's a use here for everyone. In addition to the kind of lesson that you don't want to build a robot to fix a bad connector, I think there's also a neat lesson in kind of just a super simple way to design a useful connector.
Yeah, and the other lesson here is for manufacturers of equipment like this. You're building something for mobility. Think about the possibility that someone maybe can't do, fiddly little connectors, and maybe make these things more accessible, soup to nuts, not just in the getting around, but all of it. I mean, someone in the comments did have the point that you have to stop someplace in terms of, regulatory approvals and making sure that if you do something new, chances are it's going to get on somebody's radar, and you're going to, have, an extra layer of red tape to go through. So, I mean, there is that, but still, it seems like this is a problem that Nicholas probably shouldn't have had to solve. It should have been solved by the manufacturer, but I'm glad that he found a way to solve it and found the right problem to solve.
All right, my first quick hack this week comes from Adam Beckstrom. This is vastly improved servo control, now without motor surgery. This is a further improvement on a few-year-old project of his now to take off-the-shelf servo motors and turn them into servo motors that are useful for robotics. That is, you can control not just the set position and have them slew to that as fast as they can, but you can also set the rates and stuff like that. So this takes your off-the-shelf crappy servo motor and turns it into a super robotic servo motor. And this is a really nicely stripped down, sleekified addition to this project. So I'm super glad to see this one again. Next up, Hanu Hell dodged the weird tripod robot. This is a strange little robot with an ESP32 camera module on it. It's got 3 legs, but not like you think. There's a big central one on which it can balance, kind of serves as a pillar. It's got a pivot, so it can turn around on this pillar, but then it's also got 2 other legs that are kind of like arms that go out to the side and can pick this pillar up and move it over. So it can kind of walk side to side by putting down the 2 legs, moving over, and then dropping the pillar again. Weirdest movement I've ever seen, but I really like the idea of making a small robotic tripod to move your camera around for you. And last up, Anton Janov, galvanize your grip on grep with this great grep guide. Thanks, Ryan Flowers, for that tongue twister of a title. Grep and sed are the only old school Unix command line tools that I still use probably on a daily basis, like, TR, please. But grep is totally useful, and this is a great guide to it. It's both a PDF guide and an interactive web page, so you can practice what you're learning as you learn it. Again, one of the handful of Unix command line tools that you probably should know if you want to get stuff done on the quick and dirty.
Okay, first up on my quick hacks, OpenHT Surgery gives cheap transceiver all-band capabilities. This one comes from Oscar Mike 0 Echo Tango Paul. He's a ham who managed to find one of these Baofeng wannabes, Guangsheng UVK5, little cheap handy talkie radio that's supposed to work only in the VHF UHF bands, but not anymore. Once Paul got done with it by putting in a second receiver chip, it's able now to tune all the way down to medium wave frequencies and HF bands and all the good stuff that's going on down there. Different modulation modes like SSB and FM and AM. They got a ton of features, cool stuff. The kit itself is cheap, like $16. The radio is ridiculous, $27. Ask me how I know, because I've got one sitting on the bench right next to me, and the kit is on the way. So I bit, and I'll let you know how it goes. Probably a $50 ham article. Next up, roll your own DRO with added twist. This one is from Stefano Bertelli, who is a mate of Mark over at Rotary SMP YouTube channel. This has to do with a digital readout that Stefano spun up basically from scratch, based on a Raspberry Pi, and customized to his likings. He's a skilled machinist. He's featured on Mark's channel a lot as a mentor and a reference. He's got a lot of nice machine tools. This is a DRO that's going on one of his lathes and has all kinds of custom features that are just right for his workflow, and from the look of it, for a lot of other people's too. And finally, tiny signal generator revealed. This is by, looks like James Hetfield from Metallica, but it's not. It's actually Kiss Analog, who takes the Unity UTG 962E arbitrary waveform generator down and takes a look at what's inside of it. I've got one of these sitting on my bench too, and it is remarkably tiny. Al's point at the beginning of the article was well taken, that test equipment used to be big and heavy. Now it's so light that sometimes your probes drag it around your bench as you move things around. Is that a good thing or a bad thing? That's up to you to decide. But these little function generators are very powerful. I've used them for a lot of different things. You can do all kinds of things, different modulations, arbitrary waveforms, audio, RF work, great stuff. And the teardown is useful to see what's inside.
All right, that brings us to our can't miss articles. These are long form pieces written by our fantastic Hackaday writing staff. This week I got Lewin Day's How Does Time Work on the Moon? This is kind of a think piece about what clock to use on the moon, because on the Earth we've got a lot of time zones. You know, the Earth spins around once every 24 hours, and so we've kind of cut it up into 24 slices. Ask me why there are 40 time zones for 24 possible slices, but you know. Anyway, the point is, a moon day, can't use solar time on the moon. What should you do? And one possibility that he kind of kicks off here is you would want to synchronize your future moon base to the Earth time zone, which is closely connected to it, so that, you know, you'd say running out of APL on the East Coast of America, everyone would use, you know, Eastern time zone, and you'd use Eastern time zone on the moon for your moon base. That's one possibility. It certainly is going to get weird, though, because none of this is going to match with like any of the circadian rhythm. It's 7 o'clock, time to get up and have breakfast kind of stuff on the moon, because the sun is like, you know, overhead for weeks at a time and then gone for weeks at a time. So that's clearly not going to work. Do you even need time zones then if it takes so long for the sun to get around the thing? Can you just give up and admit that you only have one time zone on the moon? I think that's probably the right answer and probably the way it's going to go. I love the question, and I love a bunch of the answers we get in the comments. The one that I immediately had in mind is, you know, where do people go on the Earth where the sun never sets on them and they have kind of the same problem? And the answer is Antarctica. If you're down at the South Pole, like, the sun sets for half the year and then it comes up for the other half the year. And when you wake up and go to sleep and whatever is, you know, you got to pull the shades, because otherwise, you know, you're trying to sleep during broad daylight for the entire summer. And in the comments, Halyard brought this one up and said, if you want to look at what time's going to look like on the moon, you should actually look at what time looks like in the South Pole Station. What's weird there, of course, is that the inhabitants all talk to their relatives who live in different normal world time zones where the sun comes up and goes down. And they kind of all adapt to those, but then have this kind of mental change from what they use as time into their home time zones. I guess I shouldn't say it's the answer, but this is my guess to what the answer is that whatever they use on the ISS is what they'll use on the moon. And that is Universal Coordinated Time. So UTC is the, kind of base time standard here on the States. It's the base time for like all of astronomy. It's the base time in the ISS. And this was pointed out by both Gravis and Nick. And they're saying, we already have space time. It's the time that they use up on the space station. And that's probably just going to get carried over to the moon.
It's still going to be a problem, though, right? I mean, I think we're much more likely to have a permanent, semi-permanent presence on the moon than we are on Mars. Mars is kind of a non-starter. But your comment in the comment section was apt, because Mars doesn't have a lot going for it, but the one thing it does have going for it is you actually still have a day that's roughly a day that we are biologically adapted to. Everything else about Mars is terrible. So you'll probably be underground on Mars anyways. Probably underground on the moon, to be honest, for shielding, or at least inside, with heavy shielding, because you don't have that atmosphere, that nice big thick atmosphere. I think one time zone probably fits for the moon because there's no real reason to coordinate between everybody who's going to be on the moon, who are probably all going to be in more or less the same place. They're going to be where the resources are. It's going to be water. It's going to be where the first people ended up, because everybody picks the best spot wherever whatever conquered territory there is. Everybody just picks the best spot naturally. The first people do. People are probably going to congregate around there and not spread out that much. So I think on the globe of the moon, which of course is rotating, but it's tidally locked to the Earth, I don't think that time zones make a whole lot of sense. We'll probably just have a single time zone. I think you're right. I think it's probably UTC. And I guess that kind of makes it easier because you're still going to need to coordinate with Earth. In a far future scenario where you're actually living there, you can choose to live on the moon. You'll probably still have people back on Earth that you want to talk to. What time do you need to talk to them? Well, it's the same problem I have when I'm talking to you. I know you're, UTC +1, I think. I'm UTC -8, so we're 9 hours apart. That's easy. I know what time it is here for you, or I know what time it is here, and then I know what that means to you. I know it's about your bedtime now, and it's lunchtime for me. And I think we'll get used to it. People will get used to got a video conference with someone on Aldrin base. What time is that? Okay, well, it's UTC, so it's 6 hours or 4 hours or whatever it is. It's not going to be a big deal. Like what's a bigger deal is going to be things like network latency and actually extending the internet out to the moon. That's probably a bigger problem. It has nothing to do with time. Well, I guess it does actually have a lot to do with time, but there's a lot of territory to cover before we get there. We're more likely to need a LPS, lunar positioning system, before anything else. And in the comments, the point was made that it doesn't really matter what time it is. It just matters what the time delay of propagation is between the satellites and the surface. And that's a bigger problem on the moon than it is on Earth, because the moon is very lumpy and there's a lot of gravitational anomalies that they're small, but they do add up after, over time, especially when you need to, precision into the, microseconds or whatever it is for GPS. So the relativistic adjustments that are going to have to be made for future lunar positioning satellites are probably going to be really interesting. But that's somebody else's problem. I don't think that's one we have to solve. That's our kids and their grandkids.
What I thought was really neat about this, though, was that the way it kind of it shines the light back on how weird Earth time zones are in a way.
Yeah.
Like we have this whole thing where we all want to be up during the daytime and sleep at night, which, I'm totally down with that.
Sure.
I'm not that much of a hacker that I don't do that. But, then there's the counter, right? What happens if a day lasts a week and you have to sleep while it's daytime? And then the answer is this whole time zone thing just doesn't make any sense anymore. There's no reason everybody should be sleeping at different times if the sun's always up, right? You can sleep whenever you want. But they'll have to work out some arrangement, and it'll probably be some weird bargaining between what the convenient times are to sleep based on the people on Earth you're talking to versus based on the other people on the moon you have to work with. Yeah, that's the other side of the time zone thing here on Earth. Here on Earth, we're constrained by where the sun is, but on the moon, they won't be. And so, other conveniences will end up taking place. But then you mentioned the difference between time on the moon and on the Earth, and that is interesting. I just looked it up. What do you guess how long it takes light to propagate from the moon to the Earth?
Oh, it's a solid second and a half, isn't it?
1.28 seconds. Congratulations, Dan Maloney.
Wow, yeah, okay.
Yeah, totally.
Nice.
And that's crazy. So that means UTC time here on the Earth, for it to be, quote, simultaneous, you just have to start worrying about whose reference frame you're in, because there's a second and a third delay between the two of them. Yikes. So, that's going to be interesting. So that actually is the wrinkle on this that I don't think anyone even pointed out in the article or the comment section. The problem isn't which time zone you pick. The problem is what you do with the second and change in between the two. Like, you say it's UTC, but UTC in whose reference frame?
Our own personal experience, you and me, every time we do the podcast and we do our clapping, 1.28 seconds sounds like a good delay between us. We've got a solid 2 seconds, and we make it work. But yeah, I mean, what does it mean? What does it mean when you can't synchronize clocks any faster than, or with any more precision than 1.28 seconds, and probably less with actual propagation delays when it goes through some sort of physical medium?
Yeah, if we're transferring files all the time and we need to timestamp them, and we need to pick the one with the most recent timestamp. This is a real big problem for big, distributed computer systems, and they really worry about getting the time right, and throwing a one and a bit second gap in there, nearly 3 seconds for the round trip. That's asking for trouble.
Well, compared to the moon, my choice for interesting articles or can't miss articles of the week is considerably more retro. The Long Strange Trip to U.S. Color TV by Al Williams. I understand only barely how color TV used to work. Obviously, it's completely different now. It's digital. Actually, a whole lot easier to understand. But analog TV back in the day, getting a color signal sent over the air is not an easy engineering feat all by itself. Designing the systems that generate the color image, whether they be mechanical or all electronic, were significant engineering projects in their own right. Add on to the complexity the fact that by the time that color TV was becoming economically feasible, there were already 6 million black and white TVs installed in the United States. And there was no way the FCC was going to let those users get stranded. Those TVs, each one of them, represented a huge amount of capital for the people who actually bought them. They were super expensive back in the day. You're talking, you probably on the order of buying a car, maybe not quite as much, but still a very expensive proposition in, adjusted terms. No way you can strand those. So how do you make a system that's both backwards compatible and forward compatible? Because you had to have color TVs that could receive black and white transmissions, but you also had to make sure all of the black and white TV installed base would be able to receive the color transmissions, and there wouldn't be any disruption of service. Not an easy problem to solve. And Al's article goes into some of the different ways that people tried to address this problem. Again, the mechanical TVs were, at the beginning, kind of looked like they were going to be the leaders, but never ended up working out that way. Interestingly enough, my dad remembered, you could buy an attachment for your black and white TV that spun these color filters in front of it and was purported to make color TV. He said that basically all it made was static because the motor would just generate too much RF interference, and you'd see nothing but colored static. So those were kind of, huckster kind of things. But there were plenty of attempts to make electromechanical color TV, and it looked like they might actually win out. But eventually, the realities of trying to deploy a device that was so mechanically sensitive and keep them adjusted and keep them in sync, it just wasn't going to work. So something electronic had to be tried. And there were tons of different attempts. Multiple picture tubes that were kind of transmitting or kind of synchronized so that they projected different colored images onto a screen. We actually ended up with those eventually, but it was not feasible at the time. They knew what they needed to do. They needed to put 3 electron guns into the neck of a tube and synchronize them. That was pretty obvious that was the solution to the problem. They just couldn't do that mechanically. They didn't have the precision needed to adjust the beams so that they hit the right points. Shadow masks made the image very dim. There were all kinds of technical problems. Along comes World War II. The process of color TV just sort of gets put on the back shelf because it's all hands on deck for other purposes. And it was after World War II that CBS and NBC kind of went to war. RCA was in there too, but they sort of pulled out and left it to CBS, who came up with this bizarro system that didn't really go anywhere, and they were getting sued too on top of everything. So they kind of quietly took back all of the 100 TV sets they ever sold and sort of dropped out of the race so that RCA could get in on things. They came up with a system that was almost there, is almost NTSC. Now, of course, I know NTSC, never twice the same color. Everybody's got their favorite, little digs at NTSC. But honestly, when you sit down and look at it, it was a brilliant solution to a constrained system. If you were starting with a blank piece of paper, you would design something completely different. But we weren't. We weren't starting with a blank piece of paper. We were starting with 6 million black and white TVs, and actually that number grew. By the time color TV was really a thing, by the mid 60s, there were massive amounts of TVs out there that couldn't be abandoned. So scoff all you want at NTSC versus CCAM and PAL, but there were constraints to that system, constraints to the design that ideally you wouldn't want to have, but we did, and you had to come up with something. And the fact that you managed to get a signal, to get a color picture signal onto a single channel, 6 megahertz of bandwidth, was absolutely amazing. One little detail I picked up from this was that, and I didn't know this, was that as soon as it looked like color TV was going to be catching on, the FCC immediately allocated the UHF band for TV use, for future TV use, on the assumption that color TV would take up so much bandwidth that you would just leave the black and white viewers down on VHF and then move all the color receivers up to UHF. Well, that didn't actually happen because of the NTSC standard, which managed to put all of this, the chroma and the luminance signal all onto one carrier, subcarrier to the 3.58 megahertz subcarrier with 90 degrees out of phase. I still only barely understand how it works. And, this coming from a guy who did TV repair for years in the analog days, or it did the job that it needed to do. It was backwards and forward compatible. And the standard, come on, it held the day for 50 years at least. I mean, until the digital age came along and analog TV got phased out. So hats off to these engineers, and hats off to Al for a great story and going through all these cool engineering details.
That wraps it up for this week's Hackaday podcast. Thanks very much for listening. To find the links, head on over to hackaday.com/podcast. And if you see anything cool or do anything cool, write us tips@hackaday.com. And until next week,
keep on hacking.
And actually, I should go look that up. That's our doorbell. I'm clicking stop.
All right, let's cut that whole thing out. Open HT Surgery gives cheap transceiver.
Take that, you podcast.